Before we leave Chapter 4, we're going to do a quick review of algebraic two-step problems. We were first working with these back in Chapter 1, and we would have x plus 3 equals 5. Again, we would work with the side with the variable. We'd work in reverse, so we do the opposite operation. So the opposite of plus 3 would be minus 3. We did it to both sides of the balanced equation. Plus 3 minus 3 would cancel. We'd have 0. The x would drop down. 5 minus 3 is 2. We do a quick check. So 2 plus 3 is 5. Everything was good. Or we had a problem where we would have 3x is equal to 15. We would work backwards again because this is a multiplication problem. We would do the opposite property, which would be divide. We do it to both sides. How many 3's in 3? 1, or basically they would cancel out. 3's into 15 is 5. Again, we do a quick check. 3 times 5 is 15. All was good. Then we did a two-step problem where we would have 2x plus 3 equals 15, where again we would work backwards, always dealing with the plus or the minus first, where we would take away 3. Again, we would put our operation signs in so we knew what we were doing. Plus 3 minus 3 was canceled. That was the first step. The 2x would drop down. 3 from 15 was 12. And then we would have to get still a single x. So we would divide by the number in front of the variable, just like we did up there. Divide by 2 to both sides. X is equal to 6. Plug it back in real quick. 2 times 6 is 12, plus 3 is 15. So we've done all of those. Nothing new there. That was just a review. The only thing we're going to do new here is simply use the same principles we have done before. We're just going to use variables, or excuse me, decimals with our variables. So we have minus 7.6. So we're going to do that first. Don't need to worry about the 2.5x, remember first. We're just going to deal with the plus or the minus part. So we're going to do plus 7.6 plus 7.6. Again, I would write down the operation signs. Minus 7.6 plus 7.6 is going to be 0. 2.5x is going to drop down. Since I'm adding, I'm going to have 0.4, so I'm going to have 20.4 on the other side of the equation. So our next step then is we're working backwards. We want to get x by itself, so we're going to divide by the number in front of the variable. Well, the number in front of the variable this time is a decimal. Doesn't matter. It's not going to change how we do the problem. Remember, I've said before, rules or processes don't change. So we're going to divide by the number in front of the variable. How many 2.5s and 2.5? 1. I have 1x. I don't need to write the 1. And then when I do my math here, 20.4 divided by 2.5, I'm going to get 8.16. I go ahead and do that on a calculator. Not a problem. So let's do one more of these. Let's do problem number 3. This was problem number 1. So I have 1.8x plus, this time, 7.6 equals 12.1. Again, we're going to work backwards. So we're going to deal with the pluses or the minuses first. So we're going to take away minus 6.7, minus 6.7. If we write the operation, we remember what we need to do. Here we had a plus. So we're going to subtract. Plus and minus goes to 0. I'm left with just the 1.8x on this side. Need to borrow there. Decimals drop straight down, remember. So 11. So we have 5.4. So our next step then is to get a single x. Going to divide by the number in front of the variable like we always do. So we're going to divide by a 1.8. 1.8. 1.8 and 1.8 cancels out. 1.8's into 5.4. 18 goes into 54 3 times, so 1.8 goes into 5.4 3 times. So again, there's nothing really new here that we're introducing other than we're using decimals to the processes we've already learned. So go slow and easy and have fun with the homework.